This video is all about factors. Every number can be made by multiplying other numbers together, and the other numbers you multiply together are called the factors. For example, you can make 24 by multiplying 2, 3 and 4. 2 times 3 is 6, 6 times 4 is 24. Therefore 2, 3 and 4 are all factors of 24. This poster is really good. It lists the factors for us. So factors of 24 are 1, 24, 2, 12, 3, 8, 4 and 6. Sometimes it can be difficult to find all of the factors of a number without missing any out. And there's two different methods, although both involve finding pairs of factors and by starting at 1. The only difference is the way we set them out. So this first method below is just what we call the T method. So for this, look at the first example. I'm trying to find factors of 16 and I always start with 1. If you look at all of the examples, the top one is 1 and the number itself, because 1 times 16 gives me 16, 1 times 24 gives me 24, etc. I then need to move on to number 2. If my number is even, like 16 and 24, I know one of my factors is 2. 2 times something. Okay, so for 16, how many 2's go into 16? 8. 2 times 8 gives me 16. 2 times 12 gives me 24. And because 15 is odd, I have to skip the number 2. Now I go to my number 3. Is 16 in the 3 times tables? Nope. Is 24 in the 3 times table? Yes. 3 times 8 is 24. Is 15 in the 3 times table? Yep. 3 times 5 is 15. Now I go on to my 4 times tables. Is 16 in the 4 times tables? Yep. 4 times 4 is 16. So actually my factors for 16 are 1, 2, 4, 8 and 16. We wouldn't normally list the 4 twice. Because though I've got to 4 times 4, I don't need to worry about 5, 6, 7, 8 because I've met here. Let's look at 24 to make this a bit clearer. So I've said 3 times 8 is 24. Now I move on to the 4 times tables. Is 24 in the 4 times tables? Yes. 4 times 6 is 24. Is it in the 5 times tables? Nope. Is it in the 6 times table? Well, yeah, because I've already got 6 times 4, 4 times 6. So then I can stop. Last example, 15. We said it was 3 in the 3 and 5. Is it in the 4 times table? No, because it's an odd number. So this is where I stop. So factors of 15 are 1, 3, 5 and 15. So as you can see, we're always looking for pairs that go together. And then once we meet the numbers at the bottom, we know we can stop. The other method, we're doing exactly the same, we're just displaying it different, and sometimes we call them factor bugs, and that can be a good visual reminder, or the word can just be that trigger to help you remember in a test. So this time, if I was looking for factors of 24, as I just did, I just put 24 in my body. And again, I always start with 1 and 24. Is it even? Yep. So I know it's 2 times something, and 2 times 12 is 24. Is it in the 3 times table? Yep. 3 times 8 is 24. Is it in the 4 times table? Yep. 4 times 6 is 24. Is it in the 5 times table? Nope. And then I'm back at my 6 here, so I know I can stop. Hopefully you've already worked out that you really need to be good at your times tables to be able to do this quickly and efficiently. Now, from this I can now list my factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Now, in your book, I'd like you to have a go at finding all of the factors for each of these numbers. When you're ready to do that, just press pause on the video. Once you've done all the factors for all 9, you can then press play and you'll get the answers. Okay, so here are the answers. How did you get on? If you've done really well, that's great. If you've made a couple of little silly mistakes, but you can see where you've gone wrong, that's okay. Carry on. However, if you're really finding this difficult or you don't understand, this is the time it's really important to go and speak to your teacher. Make sure you mark your work first though before going to see your teacher. Just as an extension, in your book, work out the factors for each of the numbers in this list. What do you notice about the number of factors for each of these numbers? Can you explain the pattern? Pause the video now while you work them out and then press play for some feedback. Great, hopefully you spotted that each of those numbers only have 2 factors. And that is because they are your prime numbers. Prime numbers only have 2 factors, 1 and themselves. So that leaves the question, is 1 a prime number? The answer is no, because 1 only has 1 factor. Another little challenge for you, work out the factors of these numbers. What's special about the number of factors each of these numbers has? Again, press pause while you work it out and then press play for the feedback. Hopefully you noticed that those were all square numbers, and so they have an odd number of factors. That is because, let's use 16 as an example. I would have 1 and 16, 2 and 8. 16 isn't in the 3 times tables, but it is in the 4 times table. It is 4 times 4. And I wouldn't write the 4 twice, so it becomes almost like my tail on my factor bug, leaving me an odd number of factors.